Hello. Welcome to the first spoken tutorial. I want to test a new way of creating a video, and for this occasion I prepared a tutorial on how you can create your own random maze generator, using the backtracking method. If you like the tutorial, don't forget to leave a like under the video. I will also be happy if you leave a comment and a suggestion for the next video. And now let's go straight to the tutorial. We create a maze using a grid that is made of individual cells, each cell of which contains 4 walls. So let's prepare 5 entity templates, also with entities. I named them up and down wall, left and right wall and middle. You can create the walls of the maze from arbitrary blocks. The important thing is that you create a welded entity from each wall, which is a pivot exactly in the center of the cell. And also don't forget to set 0 rotation for each wall. Next, we will create a global storage logic. Here we will create all the scripts, entity storage logic, and 2 entity label logics. If we have created basic logic and entities, we can start scripting. We don't have many event tiles to choose from in the global storage, so we will create instructions for all scripts so that we can call the scripts whenever and wherever we need it. The first instruction we will create will be called create grid. We will add basic values to the instruction, namely, size X, size Z, creation time, first and last cell, and offset. If you want to set the types of values, they are all numerical values, but you don't have to do that, because if you leave the value at any, you can use any value. Before continuing the scripting, let's go back to the main screen and create the logic of the reference point that I forgot about at the beginning. We will also add 2 lever entities. We will use one lever to call the script to create a grid, and the other to call the script to create a maze. In the first lever we can set the basic values. Size X is the width of the maze, size Z is the length of the maze, creating time is the time of creating individual cells, and we need it because if we wanted to create a really big maze, the game would probably freeze if we called the entire script without a time delay. The first and last cell means the entrance and exit from the maze, and the offset means the distance between individual cells. This number depends on the size of the walls and cells. When we have set the basic values, we can return to the script and global storage. We will add a loop to the instruction, specifically count from 0 to X size by 1. And let's set the calculation value to X number. Inside the loop we add a time delay, the time in seconds of real time, and we add a numerical tile to the time value in which we multiply the creation time by the X value. We duplicate the entire loop and rewrite the values for size Z and number Z. We insert the second loop into the first loop. We multiply the time delay in the first loop by the size z so that each row and each cell in the row is created step by step. Now let's move on to creating variables. Remember an important thing here. In variables you can use a local variable. This variable can only be used in one script, and you cannot transfer it from script to script. To transfer a variable from script to script you have to create a variable using the green tile with the name create variable. You can also set this variable as local or global in some cases. But this means that even if you set it as local, you can transfer it from script to script, but only within the current entity or logic. For our script, we will create a global variable called offset, and we will use a local variable in which we will insert the tile to create an entity from the template, and we will name this variable entity grid. We put the offset at the beginning of the instruction, and we put the entity grid variable in the second loop. We add other local variables and name them position X, position Z and position. In the variable position X, we insert the number tile 0 plus 0. Instead of the first 0 we insert the tile getX vector, and instead of the second 0 we insert another number tile 0 plus 0, plus we change it to multiplication, and in this tile we multiply the number X by offset. We will repeat this for vector Z as well. In the getVector tile, insert the getPosition game logic tile and mark the logic of the reference point. This point represents the starting point from where our maze will be generated. In the variable tile named position, we insert a tile of individual vectors, and then we insert our variables position X and position Z into it. We do not need to define the vector Y because we will generate the maze at 0 height, which represents the floor of the map. We add a tile to the script, attach label entity. Here we insert as an entity variable called entity grid into the entity and mark the first entity label in the logical field. This label we can name main grid. Next we add the condition tile. With this condition, we determine the first and last cell for which we will not generate walls. The condition will be read if the length of the array get entity label main grid, -1. Because the index of each field starts with a number 0. Condition continue is not equal to the value of the first cell and the last cell. Yes, in video I have mistake, I will fix it later in video. We insert 4 more local variables into these conditions, and we can copy the tile into them to spawn entity from the template. For each of these variables, we mark the entity template in which we have marked the walls of our maze. This is all for our first instruction. Now we will create an instruction to mark the first cell from where the generation of our maze will start. We name this instruction set first cell. We will call this instruction immediately after creating our maze grid, and therefore we will place the calling tile of this instruction at the bottom of the first instruction, with a time delay. We set the time for this delay by multiplying the values of size x, size z, and time creating. Do not forget to add the value of the first cell to this instruction. But before proceeding, we must go back to the first instruction and add a tile with the name add storage entity, and we will also create an entity storage on the desktop. In this storage we will create a variable with the name visited. With this we will mark each entity as visited or not visited. In the first instruction we will set this variable to false. In the second instruction we set the value to true. Before proceeding, we have to create another global variable again, and name it current cell. We will add it to the beginning of the second instruction. Into this variable we insert the tile to get array. As an array we insert the tile to get the entity label of the entity, and mark it as the first label of the entity on the desktop. As the index of the array we use the value from the instruction, the first cell. The last step is not necessary, but it is good to add a tile to write text in the console with text, for example, grid created, so that we know when these two instructions are executed. Now you can test whether your grid will be created correctly. In the video you can see that walls are created for all cells. This is caused by the error I already mentioned. In the condition I added or instead of and. This concludes the first part of this tutorial. In the next video, we will create other instructions for detecting neighboring cells using raycast, and also an instruction for backtracking. Do not forget leave like and suggestions for next tutorials.